Okay, here we have a circuit with a switch and a capacitor, and the capacitor is initially uncharged. At the instant we close the switch, we want to find the current in resistor 1, and then after a long time, we again want to find the current in resistor 1. So note that all the resistors have equal resistance, which we're going to call R. So let's start with t equals 0. So at t equals 0, there's no charge on the capacitor. If there's no charge on the capacitor, then there's no voltage drop across the capacitor, which means that the capacitor is like a wire. So at t equals 0, the circuit actually looks like this. I'm not drawing a capacitor here because if there's no charge on it, there's no voltage drop across it. So it's just like an equipotential. So now I want to know the current through this resistor. But the current through this resistor is the same current through this whole thing. So if I found the equivalent resistance for these two capacitors and this capacitor, I could find the current I. So I'm going to start by combining these two capacitors and find their equivalent resistance. These two resistors, sorry, not capacitors. So we've got 1 over R parallel, because in parallel, the inverses of resistances add. 1 over R parallel is 1 over R2 plus 1 over R3. And R2 equals R3 equals R. So this is 1 over R parallel equals 2 over R, which means that R parallel equals R over 2. So now this resistor has resistance R over 2, and it's now in series with R1. So that means the total resistance is R1 plus R over 2, which is 3R over 2. And since V equals IR, I is just 2E over 3R. So that's the current through resistor 1 at t equals 0. Now if we wait a really long time, the capacitor is fully charged. If the capacitor is fully charged, that means there's no current in C. And if there's no current here, then this looks like a hole in the circuit. So at time t equals infinity, the circuit looks like this. It's a dangling resistor, even worse than a dangling participle. So there's a hole here. So that means that this resistor might as well not even be there, so we can just ignore it. And so again, the current through R1 is going to be the same as the current through this whole circuit. So if I find the equivalent resistance, that's going to be, these are in series, so it'll be R1 plus R2, which is 2R. The voltage is I times R, which is I times 2R. So the current at t equals infinity is E over 2R.